Welcome. This content is geared toward data science students who are new to hardware acceleration and want to leverage their GPU for processing TensorFlow workloads directly on their laptops. This guide assumes a recent NVIDIA GPU is installed on the Windows 11 laptop. In this session, we'll create a Linux development environment on your Windows 11 laptop. Creating the Linux development environment provides a straightforward path to current TensorFlow GPU support and avoids some serious complexity in trying to set up TensorFlow directly on Windows. We'll enable GPU acceleration for TensorFlow on Windows 11 using Ubuntu and the Windows subsystem for Linux. We'll refer to the Windows subsystem for Linux as WSL2 moving forward. We'll install the latest NVIDIA driver on Windows, install WSL2, install Linux via Ubuntu, install CUDA inside Linux, create a Python environment, install TensorFlow with GPU support, and verify the environment with a simple script. So, why do we need to use Linux on Windows? TensorFlow versions 2.11 and newer no longer provide native, direct GPU support for Windows. TensorFlow has phased out native Windows GPU wheels, meaning they no longer produce precompiled software packages for TensorFlow to work natively on Windows. In the industry, most deep learning frameworks target Linux first, so this approach is reliable and provides some visibility into working with data science project environments and code on Linux. WSL2 runs a real Linux kernel side by side with Windows, giving you near-native performance, package managers, standard Linux tooling, and pass-through access from Linux to underlying Windows software like the NVIDIA drivers required to access the GPU on Windows 11. By following the steps in this tutorial, I successfully established an environment to run TensorFlow workloads on my laptop GPU. These were my starting environment specifications for reference. If your specifications are significantly different, you may consider doing additional research before executing the steps of this guide. It's important to have the latest driver for your NVIDIA GPU. Let's explore how to install the latest driver and confirm GPU and CUDA support. First, download and install the latest NVIDIA GPU Studio driver for your GPU on Windows to the latest version. To do this, I recommend using the NVIDIA app. Be sure to select the Studio version of the driver as Studio drivers are optimized for compute-intensive tasks. Once the driver is installed, run the Windows command and validate the driver version and the CUDA version line. The CUDA version shown is the maximum toolkit level your driver supports. In this section, we will install Ubuntu and WSL2. Ubuntu is a full Linux distribution that includes the source code for the operating system, inclusive of the shell, tools, compilers, and libraries. WSL2 enables Windows to run Linux distributions like Ubuntu natively on Windows 11. For this step, run a PowerShell as an administrator and run the commands individually in sequence. The first command enables the Windows Virtual Machine Platform, and the second enables the Windows Subsystem for Linux, WSL feature. The third command installs a WSL2 Linux distribution, in this case, Ubuntu. You will be prompted to enter a username and password for the environment. Do so and record this for reference. After setup, you'll be able to open Ubuntu from the Start menu or Windows terminal. Reboot if prompted. In this section, we'll install the CUDA toolkit in the Ubuntu environment that matches the Windows driver capability. Then we'll set path and library variables so compilers and TensorFlow find CUDA. If you do not already have an Ubuntu terminal running, go ahead and launch one from the Windows Start menu now, as the commands on the next slide will be run from within the Ubuntu environment. In this section, we install the appropriate CUDA minor version compatible with the NVIDIA driver using the Ubuntu terminal. My GPU driver is compatible with CUDA version 12.9. You can adjust the commands to use an earlier minor version if needed. Install the NVIDIA CUDA toolkit by executing the following commands one by one in sequence. Configure CUDA environment variables in WSL2 by executing the following commands one by one in sequence in the Ubuntu terminal. Execute the following commands one by one in sequence in the Ubuntu terminal to verify the CUDA version and path to CUDA libraries. Next, we'll create a clean Python environment in our Ubuntu on WSL2 environment and install a TensorFlow build that bundles the proper CUDA and CUDNN versions. This keeps dependencies isolated and reproducible. First, we need to install and initialize Miniconda for Linux in the Ubuntu environment. Execute the first 3 commands one by one in sequence in the Ubuntu terminal. Once that is complete, close the Ubuntu terminal and reopen a new one. Once that is done, run the 4th command to verify Miniconda was installed properly. Use Conda to create a Python environment in the Ubuntu terminal. Be sure to use Python version 3.10. Execute these commands one by one in sequence to create, validate, and activate the new Conda environment. With the new Conda Python environment activated, we will install TensorFlow and CUDA along with compatible GPU libraries. In addition, install commonly used Python libraries for working with TensorFlow projects in Python. Execute these commands one by one in sequence in the Ubuntu terminal. Next, we will validate that the Ubuntu environment can be used to develop in the VS Code application installed on the Windows 11 laptop. To do this, VS Code needs to recognize the Ubuntu environment as a remote development environment, even though it is running locally on the Windows machine. This is sometimes referred to as Remote WSL2. Once we confirm that VS Code can work with the Ubuntu environment, we'll select the Python interpreter we created for the TensorFlow environment and run test code. In the Ubuntu terminal, navigate to a working directory and execute the code command to launch VS Code. This will launch a VS Code instance and should load the WSL Ubuntu environment as a remote development environment. After running the command ensure WSL Ubuntu appears in the lower left corner. This confirms remote WSL is working. If you are not a regular VS Code user for Python development, take a moment to ensure the VS Code Python extension is installed in the VS Code environment. Use the left-hand menu to select extensions and search for Python. Locate the Python extension from Microsoft and install it if it is not yet installed. Finally, let's verify TensorFlow sees the GPU and can compute on it. We'll list physical and logical GPUs, confirm CUDA is built, and run a small matrix multiplication. Create a test.py file in the Ubuntu working directory from within VS Code. I have provided a GitHub repository containing the Python test file that can be used to validate a workload is being processed on the NVIDIA GPU. You can access the file at the repository indicated here and reuse the code on your laptop. Select the Python interpreter inside the WSL environment so your code uses GPU-enabled TensorFlow. The terminal at the bottom of the VS Code window should now display the environment as active. If not, you can select the Python interpreter using the command palette in VS Code. For a quick check to validate code is running on the GPU visually, you can open up the Task Manager and watch the processes occurring on the GPU. And now, the moment we've been waiting for, test to see if the TensorFlow code will run on the GPU. Run the test file in VS Code inside the Ubuntu WSL environment with the Python TensorFlow environment we created selected as the active Python interpreter. Watch the terminal output for the messages in the file to ensure that the file processes correctly. At this time, you should see a spike in memory on the GPU in the Task Manager. Watch the interpreter terminal window in VS Code and validate the processing occurs and the messages confirm the GPU was utilized. If the file runs successfully and you see activity in the performance monitor for the GPU, the environment is set up to properly leverage the GPU for TensorFlow workloads. You can now use this Ubuntu/WSL2/Python environment for creating TensorFlow projects that leverage your GPU. If TensorFlow does not see the GPU, confirm the NVIDIA GPU Studio driver is up to date CUDA toolkit matches driver capability, and environment variables are set. In VS Code, ensure the WSL Conda interpreter, where TensorFlow with CUDA was installed, is selected. Additional research may be required to match the NVIDIA driver and CUDA compatibility. I used this project as a vehicle to explore AI services. Google Gemini proved a valuable resource in educating me on the possibilities of Linux on Windows and suggesting installation and configuration commands. ChatGPT did a poor job of converting my guide summary to PowerPoint, which required a full overhaul. While tedious, using a custom Python notebook to process the speech-to-text task and store the resulting .mp3 was efficient. Manually importing the audio and configuring the PowerPoint as a video was busy work. In the future, I will create an AI agent to receive a PowerPoint file and process the conversion to a narrated video automatically. Please visit my portfolio site and connect with me on LinkedIn. I hope you found this presentation informative. Thank you.